Good morning, everyone. Sorry I couldn't be there today. I gotta take care of a sick kiddo. So here is the review, and the quiz, as you know, will look virtually identical to this. So you are going to get all this copied down with the video today, and then we'll look over it on Thursday. If we're ready, we can go second period Thursday, or we can do more review and take the quiz Friday. So again, make sure you get all of this down, and this makes the quiz very doable if you are doing your work here. Okay, so first question here, multiple choice, find the zeros. The zeros is just a term for the x-intercepts. So we come over to our graph here, and we're looking at the x-intercepts, which is at 4 and -1. So we want to look for 4 and -1, which is C, and that is it. I suppose of any of the other options, if you look through that, I guess you may think like, oh, that's the 0, and that's like 1 and +1 for x and -6 for y, or 1.5 for x. So like that doesn't make sense. So that's the vertex. Zeros deal with the x-intercepts. That's it for that. Okay, so for number 2 here, we did this formula in Desmos. Remember, you're going to plug that in to the scientific calculator. You don't need the x equals, you don't need the plus or minus, you just need the plus or the minus. That's what you're plugging in. And then you're going to take your A, B, and C and plug those values in. What that will look like on paper, I can't do it on my iPad. I can't do that. I can't screen record if I go over to Desmos. So what you're going to do is like this. You can literally type this into Desmos. You want all of this in the numerator. That's, whoops, hold on. These open parentheses. Right, so we got 4 here, and we get open parentheses, we get open parentheses, that's all underneath that, and then 2 open parentheses. And then what you're simply doing is taking and inserting your A, B, and C. A is 1, B is 5, C is -3, and I'm going to now insert those. I have B goes right there, A goes right there, C goes right there, and A goes right there. So I'm just going to go in from left to right. So I'm going to insert B here, which is 5. Insert B here, which is 5. Insert A here, which is 1. C is -3. And A is 1. It will give you a value in Desmos. When I plugged all that into Desmos, I want to round that to the nearest hundredth. Mine says 0.54138. Lists 0.54138, and then a bunch of other decimals. For rounding to the nearest hundredth, you are going to look at this third decimal place, or the third digit, and say if that's between 1 and 4, or 0 and 4, you're going to keep the 4 the same. If it's 5 or higher, this goes up, so that's why I'm at 0.54. Then what you're going to do is come back to here in your Desmos. You're simply going to come back to here. You're going to get rid of this plus and make a minus, and then you plug it into your Desmos. That's what I'm going to do. I'm just going to change that plus to a minus, and I end up getting -5.54138, and so on. I'm going to look at the third decimal place, which is a 3, and that does not round up, so I keep the decimal of 0.54 the same. Okay, for this one, we have a soccer ball that's kicked upward. Excuse me. Initial velocity is 32 feet per second, so imagine like kicking a ball, and the speed, if you measure the speed directly after it leaves your foot, or let's say you throw it, it is going 32 feet per second, which is relatively quick, but, humanly doable. So, what do they want us to find? It says find the time it takes for the ball to return back to the ground. So let's think about this as let's just think about it graphically, and then we'll figure it out algebraically. So if we're kicking it from the ground at time 0, right here, it's going to go up as time goes on. It's going to go up, but then it's going to come back down due to gravity and then hit the ground again. If you look, what they're asking for are the x-intercepts. Well, what do we know at the x-intercept? Our height is equal to 0. So algebraically, we now are going to take and plug 0 into the equation. And now we look at this and we go, okay, I have a quadratic set equal to 0. It's a quadratic because I have a squared term and a linear term. And I want to use a method for factoring this in order to solve for t. Because we know when we're in factor form, we can set both equal to 0, do the zero product property rule. So if you look at that, between those two terms, we could do greatest common factor. The greatest common factor would be a 16 or a negative 16, it really doesn't matter, and a t. Or this is like the garbage bags, what they have in common, 16 and 32, and also a t. So what would I have to multiply this on the outside by to get this? I'd have to multiply it by t. And then what would I have to multiply this by in order to get that? That would be a minus 2. The t came out front. So you don't need a t on the inside. And then also, if you look at this, why is this a minus 2? Because negative times a negative gives you a positive. Now we can set both of these equal to 0. This on the outside set equal to 0. That's like our A. This is like our B. Set that equal to 0. So if I set the first one equal to 0, negative 16t equals 0, I'm going to solve for t. You just think, I got to get the variable by itself. You have to divide by negative 16, and therefore t equals 0. And then the other one, we have t minus 2 equals 0. Solve for t. And we see that t equals 2. So when the object is at the ground, for this object moving the way it's moving, we have the equation that represents the way it's moving. The times that's at the ground is at 0 and 2. This one is our 0. That's where the ball was kicked. We want the time equaling 2 is when it hits the ground. So t equals 2 seconds is when it hit the ground. And we want to know now the maximum height. So the maximum height is right here. This is at some time, at some height, we have a maximum height. Okay, so we need to find the time first, the time that it's at the maximum height. Well, it does look like it's halfway between these, but that would be an estimate. What we did learn for certain is that the way that we find the x value, or the input, at the maximum value of a parabola, or the minimum if it's facing the other way, is the x value, the vertex, which is negative b over 2a. Negative b over 2a. So if we come over here, a is negative 16 and b is 32. This is like a, b, there is no c. So a is negative 16. So I'm going to plug that negative 16 in for here. And c is equal to 32. So I'm going to plug 32 in for there. Simplify this. That's a 32 in the denominator, or negative. So you have a negative over negative. So at a time equaling to 1, we get the height that will be the maximum. And our estimate was actually right, that this was in the middle of those two. Okay, so we'll talk about that tomorrow, if we could just use that h, or estimating that it's in the middle rather than using this negative b over 2a. Okay, so what we want to do now is take that time and plug it back into the initial equation to find the height. And let's see, right here, 1 squared is just 1 times negative 16, that's just negative 16. And 32 times 1 is 32, so I have 32 minus 16, that equals 16, and that would be the maximum height. Alright, next we're looking at the area of a rectangle relative to the sides, which we don't know the lengths. Let's say we know what area we want. We know that one side we want to be 5 longer than the other. We need to figure out what these are to get that area. Well, we use our base model for an area, which is length times width equals area. There's a reason I wrote it in that order. And the length would be x and times the width, which is x plus 5. Of course, you could think about it the other way. That really doesn't matter. And we know the area is 24, so we set equal 24. We look at that and we go, oh, the x times the x plus 5 is not equal to 0. We did this exact same thing on the quiz recently. So we're going to distribute that and then set that equal to 0. And we need, first distribute equal to 24, so x squared plus 5x plus 24. Now we want to set it equal to 0, so we subtract 24 from both sides. These cancel, and we have x squared plus 5x minus 24 equals 0, and we have a quadratic with 3 terms, so we're going to use MAF. So we have MAF multiplies to be negative 24, adds to be 5. That would be 8 and 3. Which one's negative? We wanted positive 5, so we have to make the 3 negative. So I have an x plus 8, x minus 3 equals 0. Now we set both equal to 0. And sorry, I ran out of room. I'm going to subtract 8 from both sides here, which gives us negative 8. I'm going to add 3 to both sides here, which gives us 3. That's the solving. You can't have a negative side, that's gone. Your positive side is 3. So our length equals 3. On your test, it will say over here like length and width equals. And it'll tell you which one's the length, which one's the width. It'll say like x is the length, so x should be 3. And then the width is 3 plus 5, which is 8. All right, last we have a problem very similar to what we did with the toothpicks and what we did with crossing the river. Let's say we collected this data. We have a situation where they buy pretzels in bulk and then put the pretzels in individual bags. And if we make 3 lunches, we have that many pretzels remaining. 3 lunches, 378 pretzels, 7, 306, and so on. So if we look at this, very similar to the toothpicks example and the crossing the river problem, we have a change in the x values, and we want to see if those change in the x values are the same. So we got to figure out if this is linear or not. So what we want to do is look at the change of it. So if I do 376, if I subtract these two, the difference of them is 72. Then if I do the difference of 306 and 270, subtract those, that are 36. Then you go, oh, well, Mr. Fossey, those aren't the same. But if you look, this going from 378 to 306 is 3 lunches to 7 lunches made. And if I go from 7 to 9, that goes up 36. So you have to do not only the difference of the x's, or the difference of the y's, remember you got to divide it by the difference of the x's, and now we see we get 72 divided by 4, which then gives us, if you can plug that in, gives us 18. And note that would be, I did that incorrectly. Let's go back here. I think we see that it is decreasing, but I just did that out of order. So if I do 378 minus 306, I have to go in the same order for the x's, which is 3 minus 7, which gives us negative 4, which means we are going, clean this up, sorry. We are going, each time we add a bag, we are going down 18 pretzels. So 18 pretzels remaining, which means there are 18 pretzels being put into each bag. So and we could do the same from 306 to 270, 36 now divided by negative 2. That would also give us negative 8 right here. So 36 divided by 7 minus 2, 36 divided by negative 2 would also give us negative 18. And we could do the same here. So what's happening is, first off, this does have a constant change. Okay, it's changed, so therefore it's linear. So first thing you're doing is just circle. It's a linear function that it's going down by 18 for every lunch bag. So that is our slope. And well, first, let me back up a step. X is the number of lunches made, and Y is the number of pretzels remaining. So how is that changing? Well, first off, M is negative 18 pretzels per bag. So we're going down 18 pretzels in terms of what's remaining in the bin because we're putting 18 into each lunch bag. Now we got to figure out our Y equals MX plus B. Well, like we did on the with the hexagon and the toothpicks, we could just see, oh, how many toothpicks there were for one hexagon, how many toothpicks there were for two hexagons. And we had a situation like this. It was like 1, 6, 5, 2, 2, what was it, 11, I think. And then we could go down to 0. 0 would have been 1. And then we knew that our B was 1. The problem here, it's not that straightforward because look at the numbers that we have. Are we going to want to go all the way down or go down to 0 lunches made? You could if you want to, but that seems to be a relatively difficult calculation. The other way you can do it is your point slope, which is y minus y1 equals x minus x1, and we take any of our points and plug it in for x1, y1. So how about we take the smallest x value, 378. So I'm going to write it over here. The 1 point, it doesn't matter. I could use any of the points. So 3 comma 378, and that means that for 3 bags used, we have 378 pretzels remaining. So I have y minus 378 equals negative 18 x minus 3. And now we want to solve this for y. So if I solve that for y, I'm going to distribute this. And we have y minus 378 equals negative 18x plus 54. Now I am going to continue solving for y. Note, this is just solving. I'm going to add 378 to both sides, so that gives us y equals negative 18x plus 54 plus 378 is 432. Now we have our linear equation. We can answer any questions, make any predictions, and so on. So, first question, how many pretzels did we have originally? That means we have packed no bags. So that means we have 0 for x because x is bags, and y is pretzels remaining in the container. So if we have 0 bags, we just plug 0 in for x, and if we plug 0 in for x here, we know that goes away, and that gives us 432. And that is also what our y-intercept is. Okay, so 432 pretzels was our original amount. How many bags will they be able to make? Well, let's see. So what's physically happening is we're putting pretzels into the bags. We have these many pretzels remaining in the container. We keep going until we run out of pretzels. So what this is saying is how many bags we'll make by decreasing the number of pretzels remaining to 0. And then if this is 0, this is the number of bags that will give us 0 remaining. So now we just look at this. Once you figure out how to set it up, now we just solve. Just look at this algebraically. You just exit the pretzel remaining physical situation in your mind and just solve. Okay, so let's write the next step out. Negative 432 equals negative 18x. And we get a nice round number of 24. Therefore, we can calculate that we can make 24 bags. Okay, with the remainder of your time, I'm going to have some different activities, quizzes, gim kits, whatever I can find related to these problems. See you all on Thursday.